will continue perhaps the things about regulation and how to deal with AI in general, with science and AI in the next discussion at 14 o'clock.
Today, I have brought to you a talk that is roughly split in two halves. The first one, I will introduce a particular paper that was published last year, not a paper from us, but we found it very interesting, and I think it fits this place and also this event very, very nicely. So it's called The AI Scientist by Lu et al. I will just talk about it, how it's interesting, what they claim, what it does, and also like some shortcomings, some also opportunities. And in the second half, I will go more on like broader statements of how we can interact with AI, what language modeling has as opportunities for us, and also some of our current work. All right, so the talk is, or the paper that I want to talk about first, it's called AI Scientist Towards Fully Automated Open-Ended Scientific Discovery. And they have a really bold statement. They say, okay, we have built a system mainly by combining several large language models that interact with each other. So many fully specialized large language models to have a comprehensive system for fully automatic scientific discovery. So like you press a button and then the system spits out a publishable paper at the end. Of course, that's not really what is happening there, but that's their vision at least, yeah. So it should be fully automatic. It should perform research independently, like a cluster of machines and of AI models that interact each other closely or coarsely related to how we as scientists interact with each other. So there are some idea-giving large language models, and at the end there is a peer review of large language models that review the paper, and as such it's kind of interesting. And this paper was published in collaboration with some leading universities, for example, Oxford and British Columbia, and they, at least for us, this release was pretty exciting, even if the results are not that spectacular, but the approach is nice. So the key claims is that they propose to run a fully automated AI-driven system. So this is only for one specific topic, which is machine learning research. So it's not a system that can generate papers on other fields because it has to run the experiments themselves. So it has to be runnable by code. And such as the first version is only focusing on machine learning research. But the AI scientist should automate the entire research lifecycle. So generating novel research ideas, writing the code, executing the experiments, running the evaluation, summarizing the results, presenting its findings in a manuscript, and so on. And they also have an automatic peer review, so also the AI reviews itself, more or less. And it's built to replicate, as I already said, our human research community. And you will find this, of course, in several of the aspects. And they want to diversify the research areas. This is a first prototype because it's meant to be fully automatic, and to diversify this on other modalities and on other fields. Of course, you have to think about how this would do. The cost efficiency is also one of their claims. They say, okay, this is all run on LLMs. We all know that LLMs have some shortcomings. We'll come to this, of course, later, hallucinations and so on. But also cost efficiency is one topic that they at least address in the paper, which I find nice. So they wanted to have this as compute efficient as possible, and say, okay, for a full paper, you have to spend roughly $15 in this case, and to run all the experiments and all the paper at the end for a reasonable good system. Of course, this can be more cost expensive if you run it on a very expensive proprietary LLM machine, or even less if you host it yourself, but $15 is what they state. This is an overview of what they actually do in this whole process. So this is a conceptual illustration. So the AI scientist brainstorms the ideas. I don't know if you can see my cursor or not, but at the first idea is that they have LLMs that generate ideas and plans in kind of finding innovation step. Then they have another LLM system that runs a novelty check. So, okay, from the generated ideas, which of them are regarded to be novel and interesting enough that it should be followed further and the others should be filtered out. An idea scoring step is introduced. Then you have this whole experiment iteration with other models. So all the specialized models that now have to run these or have to write the experiment code. And this is a collaboration of a system called ADA, which is a specialized code producing LLM with the LLM system that overviews the whole process. The experiments are run and maybe also updated if another LLM checks these results and sees they're not good enough, then the experiments will be redefined. And at the end, you have some plots that are automatically generated. And from all this data, from the ideas and the experiment results and plots, you have a paper write-up step where, again, large language models write a template, write the text, and also do some LLM peer reviewing. So there are some specialized large language models again. One of them should play the harsh reviewer. One of them is like reviewer 2 who has no big clue about the topic itself. And then you have the area chair LLM that contrasts all the reviews that are sent in and so on. So this is the whole overview of the system. I also want to show you just some example prompts, so not the whole thing. If you want to see more about the specific system, they have all sorts of prompts, also example papers in their repository, in the Git repository, and also in the paper itself. But here is one. So you are an ambitious AI PhD student who is looking to publish a paper that will contribute significantly to the field. You have an idea and you want to check if it is novel or not. So not overlapping significantly with existing literature or already well explored, be a harsh critic for novelty, and so on and so forth. At the end, if you put in some ideas, then the output should be a novelty score from 1 to 10. So this is just one small component in a huge pipeline of like LLM steps that are run in this AI scientist system. I have two more for you. So there's later than the experiment that is run. So here you have another large language model prompt. Your goal is to implement the following idea with a title that is put in here. Your proposed experiment is as follows, and there the elaborated idea is put in. You are given a total number of whatever runs to complete the necessary experiments, and you do not need to use all of these. Please first plan the list of experiments you would like to run, and then it should like compile a runnable set of code that is then executed and evaluated later on. And here it's the one of the very final steps. Here is an example prompt of the paper reviewing assembling. So you are an area chair as a machine learning conference, because all of these papers are coarsely related on machine learning topics. You're in charge of meta reviewing a paper that was reviewed by however many reviewers there are. Your job is to aggregate the reviews into a single meta review, be critical and cautious in your decisions, find consensus, and respect the opinion of all the reviewers. And at the end, it should also output some scores. So as you see here, it's really like tries to mimic our research environment. Here's also just as a picture only the example paper. I don't scroll through it, but let me just say, if you open this paper and like scroll through the paper and just look at it, it looks like it would be a real deal, not looking at each of the sentences, but you have the abstract, it's correctly formatted, mostly. You also have graphs, and these are labeled correctly. You have some figures, you have tables. So without looking into the details, you would say, yes, this is like a serious paper. All right, so of course, this system has some limitations. So it's, of course, does not solve science for everybody, and not even in the small subsets. But the self-acknowledged limitations that they also state in the paper are as follows. The first big limitation is that this model has no vision capabilities. Of course, there are some models that can also incorporate vision aspects, like does this paper look nice? Is this figure configured and formatted in a nice way? Is this readable for the users? All of these stuff. So sometimes the plots come out unreadable because like text is overlapping each other and the system just doesn't notice. Or tables exceed the width of the paper, which is like a beginner mistake, but the system just sometimes doesn't catch this. Or the layout is very suboptimal and everybody would say, hey, please do this a bit better. Of course, this is nothing that is too serious in my opinion. This is solvable either manually or by another system that maybe focuses more on these formatting aspects, but it is at least one shortcoming. The next one is more serious. It's that the system does sometimes incorrect things. I mean, we all know that these are still large language models. They are prone to errors. They hallucinate and do things that are not correct. And of course, also in fields that require correctness, like mathematics and coding, they can do also serious mistakes. So sometimes they misinterpret ideas. So the idea is stated, but the experiments do not follow these ideas. Sometimes they compare with baseline results that are introduced by humans at the beginning in a very unfair way and say, hey, we broadly surpass these baseline results, but the comparison is just not correct. Or they do all these typical errors that LLM just do sometimes. They cannot compare numbers correctly. They make errors when writing or evaluating the results. And maybe they don't know the magnitude of some numbers. So they want to address this, of course. There are also some partial solutions, how they wanted to address this. The first one is a very interesting one, which I find also very nice because this is all designed to be reproducible. So if you go to the paper and to the Git repository, you find the whole thing that the LLMs and the whole AI scientist system produces. So all the prompts, all the outputs, there is the code from the experiments, the evaluation from the experiments, the paper draft in LaTeX. And so you can look at all the steps of the intermediate results and try to like see where the errors have been made. So it's transparent enough, not what the LLM self do, well, they are still black boxes, but at least all the outputs and inputs from these LLM steps are to be followed and also analyzed. So that's nice. And so all the experimental results are stored. Of course, they can also, or they envision that there will be another automatic verification and reproduction step that verifies, okay, is this not only reproducible, but it's also correct. There are some bloopers which they mention in the paper, which I also find very nice, which the AI system or where the AI system tries to circumvent the limitations that it has. So this I find very amusing. For example, in one run of the experiments, it edited the code to perform a system call to itself. So it introduced just an error running itself again and again, breaking the whole system. Well, that's maybe just a stupid error. But in another example, the experiments that the AI scientists tried to run were too long. So they were too time consuming and they extended a set time limitation where they said, okay, it shouldn't take longer than this and this time. And the AI system solved this by rewriting its own code and just circumventing this time limit. So it rewrote the time limit and said, hey, now I have 10 times the time that I was allowed to. And then it ran the experiments and then everything was fine. Well, this is the first step of like automatic systems try to like rebel against us maybe. Okay, of course there are more limitations or more implications that the system has, not only incorrect stuff, but also significant potential for misuse. So it has the ability to automatically create and submit papers to venues if you wanted to let it do that. And of course, if you wanted to do that, that might also significantly increase the workload of the reviewers, which is something that we don't want. I think all fields struggle with the immense flood of papers that now are produced, and everybody struggles to get reviewers. So generating more and more of this automatically does not really help in that. It also has the potential to be used in unethical ways. So, for example, to conduct unethical research. So it could lead to unintended harm in unsafe research if this is really conducted. For example, if you want to have this system like produce code, it could also produce harmful code or computer viruses, which have to also to be prevented. Or it could like do something with the data, like publish the data that shouldn't be published. All of these things have to be considered. And also, of course, the automation could like overwhelm the academic integrity and evaluation process. So it would be crucial in this case, for example, to disclose that the use of AI was meant here. So the AI was generating these academic papers to also maintain trust. Okay, this is really an automatic paper, and this is a paper produced by human beings. They also like contrasted using either closed models like ChatGPT and Claude and whatever is there on like paid products versus open models. So both seem to work, but they say that the frontier LLMs, so the like ChatGPT, the newest version, and also Claude Sonnet, for example, have the best results, but they're still working closely to focus on the open models and have like self-improvement ambitions that use the open models to retrain themselves in this manner. So they are interested to have open models be more flexible and also maybe surpass at some point in this specific manner the proprietary models. The role of the scientists, this is their vision. So they envision a fully automatic AI scientific ecosystem that includes not only LLM-driven researchers, but also reviewers, area chairs, entire conferences. That could be possible. However, they do not believe that the role of a human scientist will be diminished. They state that the role of the scientist will change and adapt to new technologies, and AI technologies, of course, are advancing, and the human scientists will need to adapt their roles and responsibilities, for example, to have seamless collaboration between AI systems and human researchers that might benefit from the strengths of both of these parts. Of course, AI is, or at least has the chance to become an integral part of this research team if we know to at least handle the strengths and weaknesses of them properly. So what is the feedback from this? Not our own feedback, but there has been some feedback from the Nature magazine when they found out about this AI scientists. The researchers built an AI scientist. What can it do? And I will just briefly comment on or show you one comment from the Nature magazine. I will also read it out loud. So the output is not earth-shattering so far, and the system can only do research in the field of machine learning itself. In particular, AI scientist is lacking what most scientists would consider the crucial part of doing science, the ability to do laboratory work. There's still a lot of work to go from AI that makes a hypothesis to implementing that in a robot scientist, says Gerbrand Cedar, a materials scientist at Lawrence Berkeley National Laboratory and the University of California, Berkeley. Still, Cedar adds, if you look into the future, I have zero doubts in mind that this is where much of science will go. So not that strong so far, but it has strong potential is the bottom line here. There's further criticism that sounds like it is criticism just as it may be a scientist, but not a very good one. For example, the paper contains only incremental developments. I mean, we've maybe all seen papers that do these, like they just incrementally add something on top of the existing models, and now they publish something which has very low impact. And this is what the AI scientist has done so far. And most probably these papers would be rejected by editors and reviewers. As far as I know, they did not try to publish these or to hand these in or submit them. Of course, we have also seen examples where much worse created automatic papers have been published because the reviewers just didn't check enough. And so if this claim isn't true or not, I also have my doubts. And one smaller criticism was there was a huge popularity bias for references in these automatically generated papers with references with high citation counts, which is also something that many people do. So cite something that is cited much in the literature, and even if it's not that related to the topic. And okay, so that's one smaller bias here. So the AI could still automate a lot of the more repetitive aspects of research. So that's maybe one hope or strength that these systems might have. So maybe not for the true groundbreaking work that we do or want to do, but many people say, hey, I have so many ideas and so many like boring and time-consuming tasks that we have. Maybe we can use the systems for these tasks. So the potential would be, hey, we have automation in research tasks that are very repetitive, laborious, maybe time-consuming, and allow the scientists to focus on the things that they really want to do, like critical thinking, like coming up with the good idea. And for all the 100 other ideas, I don't have that much time for. Yeah, let the AI scientists do these. Of course, if you want to make this idea a bit more fruitful and a bit more capable, we need to include other techniques beyond language modeling. I mean, this was all done by just running language models all over the place for all of the tasks that we need to do. And there are some results and some approaches that have been shown to combine large language models capabilities of writing good text and all this stuff with other technologies and capabilities that are needed in a good scientific environment, like logical power. So for example, combining this with Google DeepMind to solve math problems, and have techniques of symbolic AI to say, okay, this is logical rules that are built into the system. And we do not only rely on the statistical patterns in the data, which is the only thing that these LLMs tend to do. All right, so far only on this one model. That is, of course, also to be discussed if this is a good approach or not. But maybe some broader ideas how these techniques that are also part of this paper may be useful to us or maybe not useful to us. So the first thing is, okay, the LLM revolution in scientific discovery has many aspects. So replacing specialized models or using specialized models for each task, or using unified models, which LLMs usually tend to be. So they should be capable of doing many different tasks. It's not clear which of these approaches is the best, having very specialized models that talk to each other or have these unified models that have a broader spectrum. So this is still not clear. Then in the scientific domain, LLMs have shown their potential to accelerate also scientific discovery through generation, planning, idea gathering, and all this. Of course, the training corpora that is used for all of these approaches, for these scientific AI systems, is mainly research papers. I mean, that's what we want to produce at the end, and these are what is trained, what these LLMs are trained on. But to have a really good understanding of what the research data and the training data needs to be, we also have to have rich metadata, for example, including venues, authors, references, how these papers interact from each other, how the ideas build on each other, and having these more specialized and more capable training corpora will be a much greater challenge. So here's the ugliest slide in my deck because it's just full. And the main idea that I also want to convey is very simple, that there are many or several different types of scientific LLM pre-training techniques at the moment. So for example, at the left column here, you have these encoder models, these BERT models that are trained just by pre-training LLMs with sequentialized scientific data, so text or graphs or molecules. Then you have encoder-decoder language models, which are much more like laborious and much more require much more training data with sequentialized scientific data, for example, text and tables. And at the end, you have also mapping from both of these or from different modalities like text and relevant sequences in some other spaces. So there are many different approaches how we could train these large language models. Not each large language model is trained the same way. They also have their specialities, and finding the right tool for the right task might not be as easy as just saying, okay, use language model, solve task. But there are some skills that these large language models have and might help us in, like I said, in different fields in our day-to-day work. For example, we know that LLMs can gather and analyze vast amount of scientific literature, not without errors, but yes, they can help at least to have a broad overview of the scientific field and help us stay updated by introducing, like, for example, retrieval systems that can on the spot search for more relevant papers that is stored in the LLMs themselves. So this is something that they might help us also in the long run. These models also exist in breaking down complex scientific jargon into understandable concepts for wider accessibility. So if you stumble across some paper and don't know all the scientific details, then these can be helpful for young researchers, also for senior researchers, to get a clearer idea of the main ideas of these papers. So just by gathering ideas from the source texts, they can be helpful. They can be used for data analysis, also for theoretic modeling, so helping researchers formulate hypotheses, understanding outcomes, where I say, here's my data, here's my hypothesis, how should I interpret this? And gathering ideas or just first approaches is something that these models also like found to be very useful. LLMs have more skills. They can, for example, provide methodology guidance, which means that, okay, researchers choose the right experiment and statistical tests for their research by analyzing prior literature or running simulations on synthetic data. So this is something where the LLMs might like help and try to guess what is the right method and the right simulation on this specific task. They can have prediction capabilities in analyzing prior experimental data to make predictions on new hypothetical scenarios or experiments. For example, in few-shot learning, where you give them some snippet of the data that they need to know and they project new data, and also ideas about their experimental design. For example, they can help with gaining knowledge on the field to suggest useful experimental parameters or proven setups that tend to be like best practices or techniques that researchers may also have not considered if you ask it correctly, and thereby improving experimental efficiency, or at least you can try to do that. Then one skill that is heavily used also in our field at the TU Darmstadt in the computer science department is code development. I mean, students like the capabilities of LLMs to write code for them, or at least gain first ideas about the code. And then they can see, okay, how did the LLM do that? And try to fine tune and bug fix the code themselves. But at least code development also in fields where it's not so crucial about the correct implementation, but just run the code for something that we've done several times is just something the way you can save some time. So assisting in developing code for data analysis, simulations, or smaller machine learning experiments is something where these LLMs tend to also be very, very useful. And hypothesis generation, so by connecting pieces of information, for example, also across subfields where you don't have the exact knowledge, but the LLM can gather some aspects of like publications from several fields and combine them in a kind of new way, or at least an interesting way, can get you some new ideas or expand the scope of some of your research ideas. Now, again, is a general LLM better or a very specific science LLM better? So do you want this Swiss knife that can do everything, or a very specialized tool that is good for one thing and not for many others? This is still something that has to be explored. So scientific LLMs are emerging in many different domains, not only here in this machine learning experiment like the AI scientists, but also like other domains. We have specialized LLMs for biology, chemistry, physics that have been explored, or at least tried out. And of course, some of them have mixed results, but it's still something that is very researched heavily. And they share of course, the architecture with general LLMs, but are trained and fine-tuned on very specific use cases and data. So think of them as like postgrads rather than undergrads, more domain aware, but still in need of supervision, of course. And now some future directions. So what are things that also we want to focus on? So most existing scientific LLMs are targeted on a like coarse-grained field, like, okay, this is an LLM for chemistry or for machine learning. But some of these tasks that we want to have or want to do are very highly specialized knowledge. So maybe chemistry is not enough. Maybe I need a highly fine-grained trained LLM for one specific use case that I have. And of course, then you run into the problem of where do I get the training data? But like a mix and match of these coarse and fine-grained of these specialized and not specialized LLMs is still something that is very useful to explore, because some tasks need, of course, this specialized knowledge. And then when the LLMs are pre-trained on more general corpora, you also have this aspect and this phenomenon of you have very frequently appearing signals that dominate all the parameters. So the very domain-specific rare occurrences of some knowledge may just be left out. So a general model is usually not so good in very specific tasks, of course. So there you have the idea, okay, you want to automatically curate these data sources, for example, very in-depth theme-focused knowledge graphs or corpora for specific use cases. How could we do that? Because gathering this data all by ourselves manually is, of course, something that is very slow, very cost-intensive, and not very useful in our scenarios. The second future direction is generalizing to out-of-distribution data. So in the scientific domain, it is common that the testing distribution shifts from the training distribution, which means, okay, we train on something, and then in the real world, well, the world seems to be something different. So for example, we have novel ideas in recently published papers, of course, that are not part of the training data set. So novel scientific concepts may emerge in newly published papers, like unseen molecules in chemistry, or unseen proteins, or something like this. And how could we push our current technology to generate something that it is not seen in the training data, or very rarely seen? So this is something that is not a brand new idea, but still something that is largely unexplored, in how to get how to get LLMs to use this in the pre-training process. So how can we enforce these models to generate something that is truly novel? Of course, this is something that is hard to do and still an open research project and subject. Another future direction is we could or facilitating trustworthy predictions. So what do we mean? Hallucinations, of course, is something that we all know is dangerous. It's more dangerous in some fields than others. In high-stakes scientific domains, it's of course very dangerous if the LLM produces false data, or tries to publish something with which shouldn't be published. So making these mistakes is very, very dangerous in many different aspects. And they are also working with false information. And using current techniques that are, of course, used in many different approaches, like retrieval augmented generations or live retrieval of current data to augment the information that the LLMs already have with relevant up-to-date and trustworthy information, is something that we want, that also would help the generation process of LLMs. But how can we then be sure and secure that these sources that the systems find is really a trustworthy information? So like fact checking all the information that is input into the LLM process is also something that is not easy to do. And using also cross-modal retrieval augmented generation, for example, not only have texts, but also other modalities is also something that we might want to use. Now, we've talked about so far mostly on natural sciences or computer sciences. Of course, LLMs are not limited to these fields. They also have proven to be impactful, at least in social sciences. From survey analysis to modeling agent behavior in simulations, they have been used and also like evaluated. And of course, these tools can simulate something, for example, social dynamics, or find new ways to explore complex societal questions. So also there's something that we have to explore more. And with this, I want to say something about open questions that we still have. I've talked about some of them already. For example, training data. We need training data for every specialized task that we need to or want to do. So data set scale and quality is a big problem. Where do we find these data sets? How do we make sure that these data sets do not introduce more bias and errors into our processes? Architecture and learning objectives. So how can we design better objectives than just these autoregressive prediction that LLMs do? So they are trained to predict the next word based on all the words that they've already seen. That's mostly all they do, and all the other capabilities come naturally from that idea. But is this really the correct way to envision what we want to do? So can we do something better than just these next word predictions? Then how can we evaluate these systems? Can LLMs evaluate themselves really reasonably? Or is this something that we shouldn't let the LLMs do? And of course, all the ethical implications. So I've talked about some of them already. So how can we enforce data privacy and consent in all the experiment setup, especially when dealing with sensitive data? How can we limit the system to boundaries that we define to prevent potential misuse of information, such as the potential for creating harmful substances in biology, or creating computer viruses and all this stuff. Then the bias in algorithmic decision making. So what if the LLM makes decisions that are heavily biased, and that's not clear to see in an LLM system because these are these black box systems. So maybe they can amplify also biases present in their training data, which has shown to be true, so leading to even more skewed outcomes than is in the training data. And last but not least, also equitable access. So we talk about these LLM models, we talk about the chances that they have, but how can we also make sure that everybody has access to them, and if we want to use them, have them open for also the scientific community. So this is something where we need, in my opinion, a collaborative approach, not only involving scientists, but also ethicists, policymakers, other stakeholders, to develop a robust guideline that ensures responsible and beneficial use of LLMs in science, because we don't want to flood our field with nonsense publications. We want to have this integrated in a meaningful way and something that also helps us in the long run. All right, I've also put this references here, so some of them are already in the chat section. And with that, I want to thank you. I'm at the end of the talk. I'm also, of course, here open for questions, and I hope that this was interesting to you.
Yes, thank you for this interesting thoughts. And are there any questions? If not, I want to refer to your last slide with this ethics. Do you have an idea who could be the body to bring together the different people of the different professions which you have in your last sentence, scientists, policymakers, and so on? Who might be the body to bring them together? Because I think it's just a year ago or so that in the PNAS, there was a paper protecting scientific integrity in an age of generative AI. It was, I think it was a large crowd of scientists who try to bring together some ideas. But when you told us about this literature, this first paper, what can be done with AI from the beginning to the end, I think it's just perhaps this paper is it's not enough to yes to stop some things or to regulate it. It's a bit behind the evolution of things.
Yeah. I mean, the paper is only like a demonstration, of course. It is not proving much more than some capabilities in a very specific use case and a very specific also research environment. Yeah, where does this collaboration come from? That's a very good question. I mean, of course, it has to be a larger group, maybe also a scientific project that can prove that these collaborations or that these AI integration into the scientific work has benefits and challenges and can then approach more and more stakeholders. I don't think that a large group of like everybody that I stated here, like policymakers, ethicists, scientists, can just naturally emerge from nothing. So there has to be a large group work. If this comes from like the state, I'm very doubtful. Maybe it's more of a group effort in a large application and one of the, for example, universities or something like this. But this is more something that maybe has to evolve over time. That's my idea, at least.
Yeah, there are some sentences in the chat. Please, you can also raise your hand and speak, but I just can read it. Thank you for the valuable and insightful input. I would like to raise a question regarding the distinction between delegation and the misuse of AI. At what point does the use of AI constitute a legitimate delegation of tasks, and when does it cross the line into misuse or unethical application?
Okay. So, of course, I mean, highly depends on what we also define as like our values, human values, at least. That's what it all boils down to. I mean, some people would say that reviewing a paper with AI without the other person knowing that it was reviewed by an automatic system is also something that is unethical. That's also something that is discussed here highly at the universities. So can we automatically prejudge or pre-grade student exposés with AI or something like this? So this is also something that has to be considered. Is this ethical or not? I think in these slides, I mainly wanted to say that without controlling what the AI can do and what it cannot do. We have to be highly curious and also like cautious what the results are, because for us, seeing that, okay, this system now invented a new computer virus that's highly spreadable and very good at infecting as many machines as possible. For the machine, maybe this goal is then very good and it's very proud of itself to say, to personify it a bit and say, hey, this system is very good. It solved the task. It's novel. It is very capable. All the experiments say that I've destroyed all the machines. Of course, that's not something that we want, but this is something that we have to introduce into the value model of these highly specialized machines. And one other example was, I said, okay, the program rewrote its own code to circumvent its own limitations to do something that it was not meant to do. That's also something that, of course, we have to control, right? At what point do we then use this in an ethical manner and what not? I mean, this is really open to discussion. I mean, what is unethical use of these systems? Is an automatic paper that is then reviewed afterwards and seen as good? Is this an ethical like production or not, without any human involvement? I mean, we are in a strange time and place at the moment, so who can say? We all have our opinions. I would say no. Yeah, so when does it cross the line? I think the line is changing every day.
Yeah, perhaps the line is part of the discussion. And it's another question. In science, you should learn to critically evaluate results. Do you think that LLMs are really helpful there? How can students learn this from LLM assessments?
Yeah, I mean, for some aspects, yes, they are really good at saying, okay, for example, you've made this assumption at the start of your paper and you posted this research question. This is the experiment that you try to run, and these are the results. Do they fit together? So do the results really resemble the things that you wanted to state in your research questions? In some cases, the LLMs are really good at doing that. So we are having a small test run at the moment where we want to, as I said, or I hinted at least, automatically prejudge like student exposés, so these mini thesis application forms, so to say, so experiments that are not done yet, but are planned to be done for some thesis work. And LLMs can sometimes reason well, maybe not perfect, but the crucial thing is here for 8 good evaluations and good critically thoughts that they have, they also make 2 terrible mistakes where they say, okay, this is the statement in the beginning and the results do not match these. And if you look at it, you say, okay, no, that is a very good match. So that's an error here. And maybe also the other way around. So yes, students can learn from these. I also use LLMs in many of my lectures, not as you should solve this with LLMs, but try to do it and then look critically at the results. And in some cases, you just say, okay, yes, the result is very good. In some cases, you say, no, it's not very good. And you have to find out yourself when the result is a good one and when it's not a good one. So this critical thinking yourself about these results is very important. Yeah, there's another hand symbol
Robert?
from Robert.
Yeah, that's my hand. Thanks. Yeah, it's very interesting to dive deeper also into the ethical aspects of this. In one of the previous talks, we were also talking about the topic of prompt engineering and looking at the AI scientists. It seems like a lot of thought has been given to the prompts that actually the AI scientists consist of, and I have the feeling that prompt engineering is a main topic for the future, also for scientists who want to make good use of AI. So I guess my question is then, do scientists need maybe even compulsory training in prompt engineering, or would it something be more along the ways of there is a like a new emerging job of a prompt engineer that you would hire to like do these prompts that that make your research easier?
Yeah, thanks. That's a very nice question. I mean, we've already seen in some companies that they search for prompt engineers to do various stuff, and that's a job that already exists in many places. And I'm always a bit curious about this. I mean, of course, you can fine-tune prompts to do some job better than before by trying out 10 different prompt techniques and do this also in a fine way or in a fine-grained way to try out many different combinations and see which result is then best. But in many cases, that is just void in the next version of your LLM that is then published by OpenAI, or with all your prompt techniques that work on task A do not work on task B. So this is a highly volatile field. And we've also seen many cases where small changes in the prompt have huge impact on the outcomes. In some cases, that's really visible, where you just insert a comma at some point and don't change the text, and at some point the predictions is then reversed or something like this. So I also would say that the prompts that they used in the AI scientists are, of course, important. With other prompts, the results will be different. But again, I would also only see this AI scientist project as one demonstration what you could do with these kinds of prompts in this pipeline, and making changes at any of these points would result in very different outcomes, and also, of course, changing the prompt inputs. If a prompt scientist is a really useful job in the future, I'm personally just a bit skeptical. I think this is something that can be automated if you really need the best prompt for a task X or Y with some techniques. And who knows what the next LLM will look like, if there are then new tricks that you have to find out how to best make the best prompt. So this is like, for me, it's always a bit of like black box magic.
So you would say the model is more important than the prompt?
Yeah, I mean, yes and no. So the best prompt can be then invalidated with the next model. So the model will override the prompt in many cases, yes.
And I have heard that there should be sort of agents, which are also a sort of AI, which are the prompt makers
Yeah.
for themselves, by themselves. But I don't know if this is yeah, the solution for this, or if it's just in some of these LLM.
I mean, you can try it out if you tell ChatGPT to write you the best prompt for ChatGPT for task X. So let ChatGPT write its own prompt, then sometimes the results will be better. And yes, there have been also some other cases where you have specialized agents that are then the prompt engineers for the other agents that are in the system. So you can be really creative and crazy sometimes about these setups. Because at some point I just laugh and say, okay, now the LLM is prompting itself to prompt. How deep can we go? But yeah, I mean, these specialized agents, some have also proven to be very good in many different applications. I've seen a paper that was published last month that has a bit more elaborate approach on this peer reviewing process, for example. That was also nice. So this whole system was only there to make a good peer reviewing feedback to some paper. And there you had also specialized reviewers that said, okay, you only look at the graphs and the formatting. So they had a visual component in that. And you only look at the graphical design of that and don't care about the content. And then you have one agent that says only, okay, is the research idea in the first paragraph and the motivation, is that valid? And then others do other things. And then they have a collaborative like approach where they then decide on a whole result together. So many of these agent-based approaches are explored at the moment, some with very also good results. And I'm also curious about the future about these approaches. Yeah.
Yes, you also mentioned the problem with general AI systems and specialized, because I'm from the library and we always try to tell the people, don't use ChatGPT for literature research or looking for literature, because it's hallucinating very nice things, but they are not real. And yes, that's perhaps a sort of problem that we try to tell the scientists, yes, you have to use, please, some specialized things, but everyone thinks, okay, I have just this setting and it's okay. And how do you try to bring this in the studying, for your students, when you explain them how to use AI, the thing with the general and the specialized?
Yeah, thanks. So of course that's a problem. Usually people use what they already know or what they already have access to, because it's tedious to have a specialized tool for all your use cases. Now, if I want to have literature review, I use this AI model, and then I want to generate ideas or write like a social media article, you have to use another tool and all this stuff. I mean, the crucial thing is, for some ideas, you don't need the best result in every case. Like it doesn't prove, or it doesn't have the danger to make something bad. Like if you do literature research and rely on the results and say, okay, these are then papers that I want to cite, then you have to be mega careful. And then you should use the best tool in the whole world and double check that result, of course. Yeah. If you want to just brainstorm some ideas, then you can do whatever you want. I mean, this is something that is maybe the first step of your research pipeline, and you just want to have some sparring partner, maybe some automatic sparring partners where you can just brainstorm some ideas. But yes, in the teaching, if I know that, for example, ChatGPT struggled with some things, it has been better now with citations, but it still makes some errors. In the beginning, I just shown that, hey, okay, if I now search for my best 5 publications, this is the result. All of them are nonsense. Some of them are from conferences that don't exist and all this stuff. And then I use some other tools, and you have to be, of course, aware of these errors and also aware of that there are better approaches to this. So not only every task has to be solved now with an LLM. That's the first thing. And if you use an LLM, maybe there is at least a specialized version or some more elaborate for that task that you want to do now.
Thank you. Are there any more questions? Because we always have one. Robert, you're unmuted. You want to say something, or
Yeah,
just...
wouldn't the solution be these retrieval augmented generation AI techniques?
I mean, that's a good approach. And also most of the major LLMs use that approach at the moment. So also ChatGPT has that functionality built in like a few months ago, where you search for something and it retrieves some information and builds this into the output of the LLM model. It doesn't solve the problem 100% because it still can generate false output even if you put in more correct information, but it helped immensely. And that was one of the steps where ChatGPT learned to give more correct citations. I say more, it's still not 100%. But yes, I mean, retrieval augmented generation is something that helps in many fields. Also, just from a practical standpoint, that you don't have to retrain the model every month or every week to be up to date with the current things. So you can just pull the current information from the last week's events and so from the net and use this for your generation. So this has been a good approach for many different applications.
Thanks. Maybe another issue that I find fascinating there, I read some things about, is also that well, people are saying that there is a risk of these AI models imploding because of all the AI generated content that they're trained with. And if we're looking at a fully automated AI scientist system that generates these papers, and then new models are trained with these, then you have the same problem basically. So yeah, I'm very curious to hear your thoughts on that.
Yeah, thanks. So what you're referring to is called model collapse. So that's usually what it's referring to. So if you train a model, usually what it does is generalize stuff. So all the rare occurrences that it sees in the world are usually dropped, and it's more of a like a generalized, standardized version of the world, of the language that we use and all the stuff that we do, and that's what it outputs. And if you now use this model to generate lots of texts and use this generated text to train the next model, which is used nowadays, lots of the texts that are produced are automatic, that is used to train the next model, then it learns from this generalized stuff, generalizes it even more, and from generation to generation, it could be that it's more and more useless what it produces. We've seen this in also smaller experiments where like predicting something like just here is a number I've written on a piece of paper, please predict what number it is. If you train this many times, so you train it to recognize it, to write these numbers, to then recognize it again, to write new numbers. And if you do this for some generations, then at the end, no numbers exist anymore. So it's all just mush, like some lines, and so it doesn't really learn. And in the context of these papers, of course, the same thing could happen. So if it just learns that these very general papers that it produced is now what its new goal, not our maybe better papers, hopefully better papers, is what the goal is for its training, but these more generalized papers, maybe it's just small incremental papers, and that is its new training objective, then the next version could just be worse. All these ideas of this model collapse are still only like speculations and have been proven in certain experiments, of course, in the whole overarching LLM architectures that we see. It's still that these models are getting better and better. But of course, that's a danger that still can be there. If we use these models more, they need more data, and this data is more generated, that this can still happen. So we are still curious what the future brings in this aspect.
One other idea what we didn't talk about is the money in this in this field, because many of these LLMs are very expensive if you use not the public version but something else, and there's perhaps an idea that there might be a sort of bias in the global architecture of science if in some countries you are able to pay this and in others not. And it's also the same at the universities. If some of the students, the professors or so, they can buy the good version or the extensive version and the others not. What do you think about this especially in this global thing with the community, science community?
Yeah, thanks. So yes, that's a huge issue. I mean, the whole economy and also money topic is a huge issue with LLMs. Not only are they expensive to buy these licenses, but also they just like burn energy and money in huge data centers, which is something that not many people talk that much about. So we are having these huge training cycles, which yeah, they use a lot of power for one training instance, and some of that is maybe only for some small experiment. And that's, of course, not something that is very fruitful in our economy or ecology also. So yeah, that's something. Also the access, I've hinted at one slide maybe, that of course, if you have the best model, then that gets you an advantage. Also in very small cases, like you use some LLM for some teaching, of course you have to provide this to every student. Otherwise, some students have advantages if they can buy the paid version and some others don't. So there you have to be careful. And in the end, it would be, of course, best to have free access either with open models that are very capable, that are also comparable with the paid products. At the moment, that's not really the case. I mean, there are some models that are good at reasoning, the DeepSeek model, for example, but still the proprietary models are better in many aspects. And so having huge projects that try to thrive the open source community in these LLM fields is maybe the best approach here. So I think there are some movements that say, okay, please make these open, or we together will work on open versions that are good, so that we can also use as an alternative with minimal loss in accuracy and prediction power. But this is still something I would try to see more of.
Yeah, this could be a sort of closing remark if anybody just wants to ask another question or give another remark on this, that we all perhaps have to focus on open source products and to use our brain when we use artificial intelligence. Yeah, if there are no other questions, I would say thank you to our rep and to all who ask questions and take part in our HeFDI Data Week. And we are happy to see you once again in another data week, or what we all are doing.
Thank you very much.
Yeah, thank
Have
you.
a nice weekend.
Yes, you too.
Bye.